In the grand theater of Jupiter's moons, Callisto often plays a quieter role. Unlike the volcanic fury of Io, the magnetic complexity of Ganymede, or the mysterious ocean of Europa, Callisto wears its age in every crater and ridge. But don't be fooled. Beneath this ancient surface may lie one of the solar system's most intriguing secrets. Welcome back to Infinity Beyond, where today we explore the oldest, most heavily cratered moon of Jupiter. Callisto's surface is a mosaic of impacts, unchanged for billions of years. It's one of the most cratered bodies in the solar system, suggesting that geological processes here have slowed to a crawl or ceased entirely at the surface. And yet, beneath this static exterior, there may be hidden activity. Scientists estimate that Callisto, like its sibling moons, may harbor a subsurface ocean. Magnetic field data, gathered by the Galileo spacecraft, hints at an electrically conductive layer beneath the icy crust. If true, this ocean may lie more than 100 kilometers below the surface, trapped beneath a thick shell of ancient ice. Unlike Ganymede or Europa, Callisto doesn't appear to have active tectonics, resurfacing, or volcanic activity. That might seem boring, but it also means its ocean, if present, could be chemically different and perhaps more stable over immense spans of time. In planetary science, stability can be just as important as energy when it comes to supporting life. Callisto also has a thin oxygen atmosphere. It's almost imperceptible, measured between 0.2 to 1.2 micropascals. That's roughly 100 billion to 500 billion times thinner than Earth's atmosphere at sea level. Far too thin to breathe and far too unstable to support surface life. Still, Earth has shown us that life can flourish in the most extreme environments, from deep-sea hydrothermal vents to subglacial lakes in Antarctica. So the possibility, however remote, that microbial life might survive beneath Callisto's crust is a question worth asking. One advantage Callisto has is its relative radiation safety. While Europa and Ganymede are bombarded by Jupiter's intense magnetosphere, Callisto orbits further out, beyond the most dangerous radiation belts. This could make it a better candidate for long-term robotic or even human exploration. Some scientists have proposed that Callisto could serve as a future base for missions deeper into the outer solar system. Its stability, low radiation, and potential access to water ice make it a compelling logistical waypoint. Its massive surface craters, like Valhalla and Asgard, stretch thousands of kilometers and reveal a complex internal structure, layered ice, possible liquid zones, and a rocky core. Radar instruments aboard future missions, like JUICE, will help confirm whether an ocean really exists below and what conditions might be like in that dark buried sea. Despite its ancient surface, Callisto may hold clues to the early history of the solar system. It likely hasn't undergone significant change in billions of years, meaning it acts as a time capsule. Studying its ice, rock, and trapped elements could give us insight into what the primordial solar nebula was like when Jupiter and its moons first formed. Callisto's silence is deceiving. It may not erupt or glow or roar with auroras, but in its quiet, cratered stillness, it guards mysteries as deep and powerful as those of its more famous siblings. As we continue our journey through Jupiter's vast moon system here on Infinity Beyond, we recognize that even the quietest worlds have stories to tell, some stretching back to the dawn of time. Next up, we'll zoom back out and look at Jupiter's magnetosphere itself, an invisible force field so large it would engulf the Sun. What is it? How does it work? And how does it connect the entire Jovian system into one giant magnetic machine?